Hi everyone, Keda Hale. Welcome back. Hope you're doing good. My name is Adil Khan. I'm your chemistry teacher at Base Education Services. So welcome to the Bridge Course session number 4 with the hope that you are doing safe and sound and enjoying the Bridge Course session offered by Base. So session number 4, before we move inside and discuss what is there in the session number 4, let's go back and discuss the question of the day of the session number 3. Can you recall what was the session of the 3 question of the day? Correct. In session 3, we discussed that to find out the molar mass or the molecular mass of the given molecules. So let's move forward. So this is the question of the day from session number 3. Find the molecular mass of the given compound. The first one is your potassium carbonate. Let's find out this. So potassium, it is 2 times potassium and the atomic mass is 39. Carbon is 1 time, it is 12, and oxygen is 16. The atomic mass, it is 3 times. So find out and tell me what is the overall mass, molar mass of this. Quick. Find out how much it will give. 138. So if I am writing it as gram molecular mass, as a molar mass, then it is 138 gram per mole. If I'm just writing it as molecular mass, it is 138 gram. So molar mass and molecular mass, slight difference is there with respect to 1 mole for molar mass. So 138, are you getting? Everyone got it? Good. Second one, ammonium sulfate. So there are 2 nitrogen, 1 here into 2. So 2 into 14 plus 4 hydrogens are there into 2. So total 8 hydrogen. Hydrogen atomic mass is 1. Sulfur is 1 time and sulfur atomic mass is taken as 32 atomic mass. Plus oxygen is 4 times, so it is 16. So 32, 64. Calculate this, how much it is going to give you. It will be similar to the first one, closer to it. How much? 28, 832 and 4 into 16. So the correct answer for this is 132 gram for molecular mass, whereas molar mass gram per mole, MOLE mole, the unit, okay, or MOLE mole also you can write. So 132 is the correct answer for your ammonium sulfate. It's a type of fertilizer. Third one is calcium oxide. It is also known as formula of the limestone or the marble eggshell. When you dissolve in water, it is also known as lime water, just for your knowledge. So calcium oxide, so calcium is 1 time, the mass is 40. So 1 into 40. Oxygen is 1 into 2, twice. So 2 into 16. And hydrogen is also 1 into 2 times, so twice. So 2 into 1. Find out the mass. So 40, 32 and 2. So what you get finally here? Smaller value, how much? 74 gram for molecular mass and for molar mass gram per mole. So this is your calcium hydroxide or your lime water. The next one is sodium hydrogen carbonate. It is, what is the common name for this? Baking what? Soda. Baking soda and baking powder, there is a slight difference between them with respect to tartaric acid. You can find out the difference. So one sodium, so sodium is 23 and hydrogen is also 1. So I'm just writing it as 1. Carbon is 1, so that is 12. Oxygen is 16 into 3. Rest all are 1 atom, but here oxygen is 3 atom. So 23, 24. 26, 36 and your 16 into 3, that is 48. So how much mass you will get? Find out quick. Let me know the answer. How much you will get? A little closer to 74. Slight more. So 80. 84 grams or 84 gram per mole. That is the correct answer. Now C12H22O11, you know the common name for this? You don't know? Find out. Now carbon here is 12 times. So 12 into 12, it is 144 plus hydrogen is 22 time into 1 and oxygen is 16 into 11. So 160 plus 16, 176. 176, 144 and 22 into 1. Find out and let me know. It's a very standard value. How much? 342. Correct answer. So this is 342 gram per mole. So this is with respect to C12H22O11. What is the common name for this? Something sweet in taste? Yeah, find out. Next one is your acetic acid or vinegar. It is used in your noodles and all, basically the Chinese thing. Nowadays, a lot of concepts is there in day-to-day life that in order to do a weight loss, apple cider vinegar you can utilize. So it comes from there. So there are two carbons. There is one carbon here and the second carbon here. So carbon is 12 into 2, that is 24. Total number of hydrogens are 3 and 1, 4. So 4 into 1 hydrogens are there. Plus how many oxygens are there? 2 oxygens. So 16 into 2, 32. 24, 4, 28 and 32. What is the final count you get here? Tell me in both molecular mass and your molecular mass and molar mass. 24, 28, 32. So it's close to how much? 60? Not close to 60. It is exactly 60. So 60 gram per mole. So this is the calculation of the molecular mass or the molar mass from the session 3 topic. Session 3, we discuss about atomic mass, gram atomic mass, molecular mass, gram molecular mass. It comes from there. So if it is simply molecular mass, then 138. But if it is molar mass, okay, molar mass, and is writing slow, then it is 138 gram per mole. That's how it goes. So I hope it is clear. Chalo, let's move to the session number 4 and take over. What is there in hold? You will get to know in session number 4. So Nanu Yaru, who am I? What do you think? What is this? Himalayan salt, pink salt, correct. What is this? Tea chocolate? Na. It is soap. Okay. And what is this? Fruits. Which fruits? Citrus. Correct. So that is salt. This is soap and this is fruit. So salt, soap contain bases and fruit contain acid. So the next topic in this session is acid, bases and salt. Three important chemicals which we use in our day-to-day life. For example, when you eat orange, you are eating citrus fruit. When you are eating apple, it is a malic acid. In oranges and mosami, you have citric acid. In tomatoes, and tomato has oxalic acid, tamarind has tartaric acid, milk has lactic acid. Similarly, the toothpaste, it contains NaOH, which help to remove the plague, whatever your pronunciation is, from your mouth, so that the cavity doesn't take place. Even the milk of magnesia is there, which is used as a aid for digestion. It helps in digestion. That is also a type of base. Salt, you have table salt like NaCl, then you have Epsom salt. Epsom salt is like magnesium sulfate. It is a laxative action, clear your digestion and your stomach. And it is also anti-inflammatory, that whenever you have swelling in the part of the body, you use Epsom salt in the hot water and just keep your leg or hand or any part of the body there. It will be reducing the inflammation from that part of the body. So acid, basis and salt are very versatile, universal concept, very important concept we use in our day-to-day life. Curd, if you eat, there you have acid. Majige, if you make, there you have acid. So you will encounter this in our day-to-day life. So nanoyaru means your acid, bases, and salt. We identified. Good. So let's move to the next topic. Now, acid, bases, and salt. Acid and bases, they are the most familiar of the all chemical compounds. So acetic acid is used in vinegar, citric acid in lemon and other citrus fruit, tartaric acid in tamarind, magnesium hydroxide in antacid. Ammonia is used in the cleaning agents of our houses. So they are used in our day-to-day life. So if I go and talk about the earlier classification of acid and bases, they were classified on the basis of their taste and their physical feel. Okay. First time in the year 1800, there were two scientists, Davy and Faraday. Okay, Davy and Faraday, Humphrey Davy and Michael Faraday. They found out the concept of acidity and basicity, but later there was another person, Sorensen. So he gave more in detail about the pH and the acid and the basic part. So the initial concept in 1800 was given by Davy and your Faraday, just for your knowledge. So classical concept of acid and bases, the earliest classification of substance into acid and bases was based on their characteristic properties of each other. We are going to discuss that. So basically the fruits, they contain acid, citric fruit, so they contain citric acid. And here you have soap and your shampoos, they contain bases. Most of them contain NaOH and few other different type of bases also. So let's move inside and discuss how was the initial classification of acid and bases done. So acid is a substance when you take in an aqueous solution. It means when you dissolve in water, then it will have some peculiar characteristic. They will have sour taste. Sour taste, why? Because our tongues, they have receptor. Okay. And that receptor, when it come in contact with the proton, that is the H plus ion, it send a message to the brain that something unique is there and that something is nothing but the sour taste. Okay. So acids are sour. So if you are more acidic, you are more sour, or if your pH is too low, you are again more sour. Next is they turn blue litmus red. So when you see here, this is acid solution. Suppose I take it as HCl in water, which I called it as aqueous HCl, and I dip litmus paper. Litmus is what? It is a type of an indicator. Indicators are those substances which change color when they come in contact to acid and bases. So litmus is there, which is produced from fungi and algae from lichens. It come out as the form of the dye that we dissolve in some proper amount to make it litmus. Along with litmus, you have other indicators like phenolphthalein is there. You have methyl orange. Then you have thymol blue, and many other things are there, malachite green and all, various other type of indicators are there, natural and non-natural also. For example, the colored cabbage is also the indicator. So you would have done in your lower classes that. So they turn blue litmus red. You can see here, this is a blue color litmus acid solution. It is becoming red or pinkish in nature. Metals, they react with, acid, they react with active metals. Active metals means the metals which is ready to react, very reactive, or the metals in which the valence electron are either 1, 2, or sometimes 3 also. So valence electron 1 or 2, highly reactive metals. So they react with metals like sodium, magnesium to liberate hydrogen gas. So if I give you an example on this, suppose I take hydrogen chloride aqueous in the form of water, because if you just take hydrogen chloride as gas, HCl gas, they are not acid. HCl gas become acid the moment you dissolve in water. Why? I will tell you after some time. And when I make it react with sodium, so the reaction, that is the yield, what it will give, you are forming sodium chloride. Along with that, you are forming hydrogen gas as a molecule. So in order to balance this, I am using the stoichiometry like this. So I'm getting 2 NaCl, and this is the hydrogen gas. That's why we write upward arrow. And hydrogen gas is important for us for various reaction. You will read with time. So sodium chloride is formed. So they react with active metals. Active metals means they have either valence electron 1 or 2, where electrons are ready to react in order to become stable. Next is they react with carbonate and bicarbonate to give carbon dioxide gas. Example again, for example, I take HCl and it is aqueous again, okay? And when I treat it with what one? Sodium carbonate. So what you get as the product is you will be getting NaCl again, sodium chloride, and along with NaCl, what do you get? You will be getting your carbon dioxide as a gas. What you will get other than that? 2 NaCl. So this is 2 times. What else you get? You get hydrogen gas also or something else? Water. What you will get? Water. HCl, Na2CO3, NaCl, carbon dioxide. This is 2 times, correct? And 2, correct. So 3 H2O, water is formed, not hydrogen gas. It will give rise to your water. The next one is it is going to neutralize base. Whenever you take acid and bases, now I will be representing acid as A bar and bases I'm going to represent as B bar. So whenever acid and bases they react, it will undergo neutralization to form salt and your water. So this reaction is known as neutralization reaction. More in detail we are going to do soon. So this beaker is clear. I believe you know how it looks. That beaker, when I take a base here, for example, I take sodium hydroxide. Sodium hydroxide is like a tablet of dolo. When you dissolve in water, it becomes sodium hydroxide aqueous. So I'm writing it as sodium hydroxide aqueous. And when you dip the pink color litmus or the red color litmus, it becomes blue in nature. So in acid, blue become red. In base, red become blue. So blue litmus become red and here red litmus become blue. So there's a cheat code for this. I will explain you after this slide. Let's go and discuss something about base. Now, base is the substance in aqueous medium. That is, when it is dissolved in water, it will have the following characteristic. First one is it is bitter in taste. So that total there are 5 type of taste. 5 major type of taste in human. What are the 5 major type? You can find it out. Okay, total 5 types. Now it is turning red litmus blue. So please remember that. Now, in order to remember this, I have a cheat code. Cheat code is whenever we get hurt and whenever we are in pain and if we are closer to our father, we use this word. It is Baap Re Baap. Baap means father. Or we can use Are Baap Re. Are Baap Re. So when I was of your age, couple of years back, not couple of years back, decade back, I made this cheat code, Bapre Bap and Are Bapre, because I was always confused about the color of the litmus. So Bapre Bap stand for basic solution turn red litmus into blue. B for basic solution turn red litmus into blue. And acidic solution turn blue litmus red. That is Bapre Bap and Are Bapre. Basic solution turn red litmus blue, whereas acidic solution turn blue litmus red. You can check here. They turn red litmus blue base. So red litmus blue. So remember Bapre Bap and Are Bapre. Life will be easy. The third is they have soapy or slippery touch. What is the reason behind it? For example, bases, when they dissolve in water, they produces hydroxide ion, OH minus ion known as hydroxide ion. And suppose this is your skin. When it come in contact with your skin will be having 2 important things. It is containing oil and it is also containing fat. Now this OH minus, when it come in contact with your skin containing oil and fat, it will break oil and fat. When it break oil and fat, it will produce a slippery nature or a soapy nature. So That's why it is slippery or soapy nature, because the OH minus ion, hydroxide ion, when it come in contact with our skin, which contain fat and oil, so they break fat and oil, and due to that slippery nature it gets. That's why it is slippery or soapy in nature. So that is important with respect to slippery and soapy part. And next is they neutralize acid. Just now we discussed about neutralization reaction. A bar means acid and B bar means base. When you treat them, then it form two universal compound, that is salt and water, H2. Whether you are in India or it will give salt and water. Correct answer. So this is with respect to the earlier concept of acid and bases. Somewhere in early 80s and 90s it was used. Now the modern day concept, there are 5+ concepts involved, but when you come to 11th and 12th, we will teach you only 3 concepts of acid and bases. The first concept is Arrhenius concept, which was given by a Swedish scientist Arrhenius in the year 1887. Then there is a Bronsted and Lowry concept given by Bronsted and Lowry uncle. Then there is Lewis concept given by Lewis uncle. These 3 we are going to discuss in class 11th and 12th also. Other than that, you have another 2 concepts. Okay, one is known as Lux-Flux concept and Usanovich concept, I believe. So these 2 are the other concept, Lux-Flood concept and Usanovich concept of acid and bases. But important ones are Arrhenius, Bronsted and Lowry, and your what is that? Lewis concept. So we will focus only on that part at this point of time. Now let's discuss the first concept, which was a very old and the nascent concept known as Arrhenius concept. Arrhenius concept was given in the year 1887. So what is Arrhenius concept is that when you take a acid and dissolve in water or mix in water, it produces always one specific ion, that is H plus ion known as proton. So either it can liberate 1 H plus ion or 2 H plus ion or 3 H plus ion or 1 mole of H plus ion. 1 mole is nothing but Avogadro number, last class we discussed. Okay, so Arrhenius concept, it was given by the Swedish chemist Arrhenius, established the relation between acidic behavior and the presence of hydrogen in the compound. Basically hydrogen must be present in order to come out as H plus ion. He also introduced the idea of dissociation of the compound. Dissociation of the compound means when I take HCl in the form of gas and I dissolve in water, which is liquid. Now your HCl is undergoing dissociation. So it will dissociate to form H plus and Cl minus. So this process is known as dissociation or ionization. But there is a slight difference between dissociation and ionization, which we will discuss in our physical classes. Now, since this is H plus and this is Cl minus, the water molecule is still there. So that water molecule is going to link to this. So it will become H plus aqueous and Cl minus aqueous. Since H plus is positive charge, the negative part of the water will be linked to it. And since Cl is a negative charge, the positive part of the water will be linked to it. So this is known as hydrated proton and hydrated chloride ion. So this make acid as the acid, and this concept is known as dissociation and or association for you at this point of time. According to Arrhenius theory, an acid is a substance which dissociate or break in water in aqueous solution to give hydrogen ions or proton. So H plus ion or proton, they have the same name. So if you are Arrhenius acid, you will always produce H plus ion when you are present inside water or you are mixed in water. Without water, Arrhenius concept is not applicable. One of the major demerit of the Arrhenius concept that it cannot explain about acid and bases in the absence of water. Water is a mandatory criteria. Okay, let's move. What happened to this? Okay, let's talk about the Arrhenius acid. So this is my HCl. I am taking it as aqueous. Aqueous means water is there. So it is breaking as H plus and Cl minus, aqueous and aqueous. This is known as water of hydration, hydrated ion, hydrated ion. Hydrated H plus ion, hydrated Cl minus ion. Cl minus is known as chloride. Whenever Cl is like this, it is known as chlorine. Whenever Cl is in the negative form or anion, it is known as chloride. And whenever Cl is in the positive form, which is also possible, it is known as chloronium. Chlorine, chloride, chloronium. So whenever you end with ide, you are negative charge, and whenever you will end with ium, you are positive charge. Chloronium, bromonium, fluoronium, like that. Okay. So it is H plus and Cl minus. So this H plus make it acidic in nature. Now, suppose I take it as, okay, suppose I take it as a gas. So HCl gas in the presence of water, it is giving me H3O plus and Cl minus. Why? Because H plus is highly unstable and reactive. So it do not want to stay alone. The moment H plus is formed, it is going to react with someone. So what H plus do? It go and react with water to form H3O plus. So whether you write H plus ion or you write H3O plus aqueous, hydronium ion, proton or hydronium ion, it is same. This also represent that it is acid. This also represent that it is acidic in nature. Okay. For example, this is my HCl, hydrogen chloride gas. It is closed. This is the closed container. There are three types of container. In future, you will read open container, closed container, and isolated container. Open container means mass. The energy can also come out, and even the mass can also evaporate or come out. Okay. So in future, you will read that. Now, this is your hydrogen chloride gas without water. The moment I add water to this, I am adding water. So this part is nothing but water, the blue color. My HCl is breaking as H plus ion and Cl minus ion, proton and chloride ion. So this proton which is produced, it is responsible for acidic nature of HCl. So HCl gas is not considered as acid, whereas HCl aqueous is considered as your acid. So HCl gas is hydrogen chloride gas, whereas HCl aqueous is hydrochloric acid. So please remember that. So HCl liquid is going to corrode your skin when it falls, whereas HCl gas can irritate your skin, but the corrosion is less possible. Corrosion is possible to some extent because of the moisture content on the skin part. So example of areneous acids are HCl, hydrochloric acid, nitric acid, sulfuric acid, phosphoric acid, carbonic acid, and acetic acid. Carbonic acid is present inside your cold drink, soft drink. Acetic acid is in vinegar. Sulfuric acid is known as king of chemicals. It is highly strong. Now, what is the similarity between all this presence of hydrogen, 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 and your hydrogen part? Now, here there is one hydrogen, here there is one hydrogen, here there is two hydrogens. So these two hydrogens are more stronger. That's why sulfuric acid is more stronger than nitric acid and HCl because of two hydrogen. Phosphoric acid is having three hydrogen. This is having two hydrogen, and here you feel there are four hydrogen, three here and one here. But for us, the important one is this. This is the acidic hydrogen, not this. In future, we will discuss all that. So in nutshell, if your acid is containing more number of H, which come out as H plus, it is highly strong or a stronger acid. But if it contain more number of H, and most of them are not coming out as H plus, then it is not a stronger acid. In order to make you a stronger acid, your H must come out as H plus ion. That is the criteria. So that's why in acetic acid, even though 4H plus is there, it is a weak acid, not a strong acid. Similarly, carbonic acid is a weak acid. And these two acids are known as organic acid. Why organic? Because carbon and hydrogens are there. And these three are known as your mineral acid. Why mineral acid? Those four, HCl, nitric, sulfuric, and phosphoric, because there is absence of carbon and hydrogen bond there. So these four are mineral acid, and these two are your organic acid. So acids are also of two types, mineral and organic, just for your knowledge. So this is Arrhenius concept, that is presence of H plus ion in the presence of water. Correct. Let's move to the next slide. Now, according to this theory, Arrhenius base is a substance which dissociate or break in aqueous solution to form hydroxide ion. What is hydroxide ion? OH minus ion, and since it is present in the, since it will be present with water, OH minus aqueous we write AQ. For example, I take it as NaOH and this is the water symbol. So it will form sodium ion and it will form OH minus aqueous ion. So this is responsible for the basic nature of NaOH. NaOH is basic due to presence of OH minus hydroxide ion. Now let's take this example. For example, I add sodium hydroxide pellet or capsule inside it. It looks like Dolo tablet. Dolo, you know, white color, small, round tablet like that. So when I add sodium hydroxide pellet inside it, in the presence of water, my sodium break at Na plus and OH break as OH minus. So this is responsible, OH minus is responsible for basic nature. And they both are hydrated. Hydrated means water molecule is linked. That's why Na plus aqueous and OH minus aqueous we are writing. Without water, again, NaOH is not a base. In the presence of water, when OH minus comes out, then only it is an important base. Examples are sodium hydroxide, potassium hydroxide. Then you have calcium hydroxide. It is also known as your lime water. Lime water and lime juice difference is there. Lime juice contains citric acid, whereas lime water contain OH minus ion. So lime juice is acidic and lime water is basic in nature, not same. Then you have magnesium hydroxide here. Now one more concept here. Here there is one OH minus, one OH minus, two OH minus, two OH minus. More the number of OH minus, more stronger base you are. Less the number of OH minus, less or weaker base you are. But if suppose there are 4 OH minus, all 4 come out as OH minus, then only it is a strong base. But out of 4, only 2 is coming out, it is a weak base. Irrespective of the number of OH minus, the OH minus must come out as OH minus when water is added. The presence of OH is not important. OH must come out as OH minus, that is important. Okay, remember that. So note, the Arrhenius theory is applicable only in the aqueous solution in the presence of water, one of the important demerit of the Arrhenius theory. But Arrhenius theory still give us the basic idea about that acid and basis differences. Acid will give H plus ion in the presence of water and basis will give OH minus ion in the presence of water. If you know this much, can you tell me which acid is present in soil? One important acid, start with F. You have any idea? You don't have idea. Chalo, find out and let me know in the coming session which acid is present in your soil. So let's move to the next topic. This is done. So F. You want the answer? Fulvic acid. In soil it is present. FULVIC. Now let's move to the next part. Now acid and bases are of many type, but for you there are two important type of acid and bases. One is strong acid and one is, there are two type of acid, strong acid and weak acid. Two type of bases, strong base and weak base. So basically you have strong acid and strong base and weak acid and weak base. How to differentiate them? For example, you take a strong acid and dissolve in water, the entire acid break as H plus ion and whatever is the counter ion like Cl minus in the case of HCl. Whereas weak acid, if you dissolve in water, only partial dissociation take place. Let me give you an example on this. For example, you have HCl and you treat it with water. It break down as H plus aqueous and Cl minus aqueous form. Okay. Entire HCl is breaking down as H plus and Cl minus. Then this type of acid is known as strong acid. And here is a concept known as degree of dissociation, DOD, represented by alpha. It is considered to be 100%. That the entire 100% of the acid is breaking down into H plus ion and Cl minus ion. Degree of dissociation represented by alpha. So entire thing is breaking down. If suppose I start with 1 kg of HCl, entire 1 kg is breaking down. If I start with 100 gram of HCl, entire 100 gram is breaking down. That is known as weak acid. If I talk, sorry, strong acid, that is known as strong acid. If I talk about weak acid, then you take acetic acid into consideration, vinegar and water. Acetic acid break into two type of ion. One is acetate ion. The bond is breaking here, okay? Acetate ion, and then you have H plus ion. So acetate ion is also linked with water aqueous, and H plus is also linked with water aqueous. So basically what I mean to tell that if you take 1 kilogram of acetic acid, initially only 300 gram of acetic acid is breaking into acetate ion and H plus ion. Later when you add more water, some more amount of acetic acid will break. Later when you add more water, some more amount of acetic acid will break. So in this case, the degree of dissociation, that is DOD, is less than 100%. Less than 100%, the degree of dissociation. HCl, whatever amount you take, you add water once, everything will break. Acetic acid, you take X amount, add water, some amount of acetic acid will break. Add more water, some more amount will break. Add some more water, some more amount will break. So in case of HCl, which is a strong acid, in one shot, the reaction complete. But in acetic acid, the reaction keep on going, breaking into acetate ion and H plus ion when you add water to it. So degree of dissociation 100%, less than 100%. So this is known as strong acid. This is known as weak acid. The same concept is in the case of bases. Strong bases are those when you add water initially in the start only 100% of the base will break into OH minus and the counter ion part, whatever is the ion like Na plus and K plus. Weak bases are those initially when you add water, some amount of base will break into OH minus and the counter ion. When you add more water, more OH minus is breaking and counter ion is breaking. So strong base also has degree of dissociation 100% and weak bases, they have degree of dissociation less than 100%. So this is all about your type of bases, that is the strong and the weak. So substance which dissociate completely when dissolved in water are called as strong acid and strong base, whereas those dissociate partially, incomplete, are called weak acid and weak bases. Water dissociate into H plus and OH minus ion, water. Hence, it can function as both acid and bases. Therefore, water is known as amphoteric. So there is a special type of compound in nature known as amphoteric compound. Amphoteric compounds are those which can act as both acid and base, like water, H plus and OH minus. Similarly, ammonia can also act as acid and bases. It can act as acid and bases. Okay, later, not now, you will get confused. It acts as both acid and bases because it can form NH4 plus and NH2 minus. I'm not giving you that now. Similarly, aluminium hydroxide, it can also act as acid and base. Similarly, zinc oxide, ZNO, it can also act as both acid and base. So they all are amphoteric in nature. Amphoteric in nature means they can act both as acid and bases. Now, that's all about your acid and the bases part. In today's session, we discuss about Arrhenius theory. Bronsted-Lowry-Lewis we will discuss in the equilibrium chapter when you join college physically. We are going to discuss there. Lewis concept is with respect to the lone pair of the electrons, gain and loss. And your Bronsted-Lowry is with respect to your H plus ion and OH minus H plus ion gain and H plus ion loss. So we will discuss that in future. So Arrhenius concept in nutshell, acids are those which produces H plus ion in the presence of water, and bases are those which produces OH minus ion in the presence of water. That's for you. Now let's come back and start salt. What do you know about salt? How it is produced? Acid react with bases and it will give salt and water. You know how much amount of salt our body is having? Close to 250 grams. 250 grams of different type of salts our body is having. Do you have any idea how many different type of functions salt can exhibit in nature? 14,000 plus different type of functions are noted by the salt. The few important function of salt for human body is maintaining our blood pressure. You get angry, no, because of that blood pressure. Second is your nerve conduction. It maintain your muscular movement and the nerve conduction. And third, can you find out what is the another important function of your salt? Find out and let me know in the Cubase forum. There are many more. I am not going there. So salts, they are very important part of human life. Like NaCl is the important salt, ammonium chloride is the important salt, and there are many more salts are there. Uh, Epsom salt, I have given you example in the starting only, but when you dissolve in water, it has laxative property and it is anti-inflammatory. Anti or anti-inflammatory, the pronunciation depend on you. So salts, they are basically acid and bases. It is giving rise to salt and water. Now, few of you will ask, sir, Epsom salt, can you give the formula? So just for your knowledge, magnesium sulfate. So acid plus bases will give you salt and water. It's a type of neutralization reaction where the reactivity of acid and the reactivity of base is reduced and make a very simple type of compound, not simple, a compound which is generally less reactive in compared to acid and bases. It produces salt and water. Now salts, basically they are ionic compound. What do you mean by ionic compound? They produces ion. For example, NaCl, table salt, the ions are Na plus and Cl minus ion. So ionic compounds are those which is made up of ions, or ionic compounds are those which is made up of metal and non-metal by complete transfer of electron, just for your knowledge. So ionic compound that result from the neutralization reaction of acid and bases. Salts are made up of positively charged ion known as cation or basic radical, and negatively charged, which is also known as anion or the acid radical, which can either be organic in nature or inorganic in nature. Organic in nature means today only we discuss no acetate ion. So this is negatively charged anion, acid radical, but it is organic because of presence of carbon hydrogen bond. Similarly, you can have carbonate ion, CO3 2 minus. This is organic or inorganic? It is inorganic. Why? Because there is carbon, but there is no hydrogen. In order to be organic, there must be a carbon hydrogen direct bond or presence of hydrocarbon. Similarly, you can have ions like SO4 2 minus, even the barium ion is possible. So both organic and inorganic possible. So this is your organic, this is inorganic, inorganic type of ions. Now let's check example. HCl and NaOH, when they combine, it give rise to NaCl and water. H2SO4 and calcium hydroxide. So what we see here is calcium is going to react with sulfate, and this OH and H will form water. Why calcium and sulfate react like this? Because calcium is Ca2 plus and sulfate is CO4, SO4 2 minus. They have similar type of charges. So similar type of magnitude, not charges. They are plus and minus. So it will form CaSO4, calcium sulfate. And water is formed. This is simple neutralization reaction. Now, let's discuss the type of salts. You have various different type of salts. Not only these, more than this are there, but these are the primary important ones. So you have simple or the neutral salt. You have acidic salt, basic salt. Then you have double salt. Then you have complex salt. Then you have mixed salt. Many are there. But let's focus on these four. Simple or neutral salts are those salts which are neither acidic nor basic, or the number of positive charge and the negative charge, or let's not go there. You just remember that they are containing one type of cation and one type of anion, and neither H plus is more nor OH minus is more. And moreover, they are made up of strong acid and strong base. So that is a better explanation for you. So simple or neutral salts are made up of acid and base, or strong acid and strong base. For example, NaCl is made up of a strong acid like HCl and strong base like NaOH. So they are the salt between strong acid and strong base, better one. Acidic salt, name only suggests that when you dissolve in water, they are acidic in nature. Why they are acidic in nature? Let's find out that. So they are formed when strong acid react with weak base. So the first one was strong acid, strong base ka reaction. Here you have strong acid and weak base ka reaction. So weak bases are those which undergo partial dissociation. It means if suppose this is giving out 10H plus ion and weak base is giving out only 5 OH minus ion. Why 5? Because it is weak. Then your reaction will be between 5H plus ion and 5 OH minus ion only. They will only react and neutralize to form water. Still 5H plus will be left. That 5H plus is making it acidic. So acidic salts, they are formed between strong acid and a weak base, result in acidic salt. There is an incomplete neutralization of the acid. It means the entire acid is not consumed, which result in salt having a pH below 7. What is pH? We will discuss today. Power of hydrogen or potency of hydrogen, the full form. pH below 7, that is acidic in nature, showing an acidic character. For example, if I talk about acidic salt, one of the famous example is this ammonium hydroxide. So ammonium hydroxide is made up of a strong acid HCl, strong acid, and it is made up of a weak base like ammonium hydroxide. So strong acid means more H plus ion is there, less OH minus ion is there. So that less number of OH minus ion react with equal number of H plus ion, some amount of H plus will be still remaining there. So this is example of your acidic salt. Another example is ammonium sulfate. Ammonium sulfate means this SO4 come from sulfuric acid, which is the strong acid, and ammonia come from ammonium hydroxide, which is a weak base. So strong acid and weak base, this is the example for your second one, the second type of salt. Now let's talk about the basic salt. So I think you can relate. Basic salt is formed using a strong base and a weak acid. Strong base means if suppose you have a base which produce 12 OH minus ion and you have a weak acid which produce 6 H plus ion. So when it undergo neutralization, 6 H plus react with 6 OH minus. So 6 H plus react with 6 OH minus to give you water molecule. Okay, you can calculate how many water molecule. Still, out of this 12, 6 OH is still left. That 6 OH make the salt basic because OH minus is basic in nature. So it is formed by the reaction of a strong base and a weak acid, result in basic salt. Hence, there is an incomplete neutralization. Again, neutralization is not complete. What do you mean by that? 12 and 6. So 6 and 6 will react. 6 is still left. So that's why incomplete neutralization of bases. And in this, the pH will be above 7. Above 7 means towards the basic range. 7 is the neutral pH, below 7 acidic, above 7 basic. And it shows a basic character. Example of this is known as sodium acetate and sodium hydrogen carbonate. So sodium acetate, this organic salt is made up of two different type of chemicals. It is made up of sodium hydroxide, which is a strong base where dissociation is 100%, and it is made up of the weak acid, acetic acid. So strong base, weak acid, it is giving rise to this. This undergo 100% dissociation to give more OH minus. This undergo partial dissociation to give H plus, less H plus ion. So less H plus ion means more OH will be there. That's why it is basic in nature. This is the third one, basic salt. The last one is double salt. Double salts, basically, it is made up of more than one type of anion and cation, just for your knowledge. It is made up of more than one type of anion or cation, or in simple term, it is made up of two simple type of salt. Two simple salt it is made up of. So double salt have more than one anion or cation in their composition. Such salt are most stable in the solid form. They are unstable in the liquid form or aqueous form, because the moment you add water, it dissociate or break into ions. So double salts, two definition. Either they have more than one type of anion or cation, or they are made up of two or more than two also sometime type of simple salts. Now, what is the example of this? This is potash alum Or I can give you example of carnallite also, that is KCl dot MgCl2 dot 6 molecule of water. This 6 molecule of water is water of crystallization. This dot means there is a weak interaction. There is no strong bond, weak interaction. So KCl is one type of simple salt. MgCl2 is another type of simple salt. So it is made up of two different type of simple salt. And the cation here is K plus and Cl minus. Cation here is Mg2 plus and Cl minus here. So two different cations are there, potassium ion and magnesium ion, and chloride ion and chloride ion. Water is inorganic part. It is just water of crystallization, or even you can take potash alum or moher salt also of iron sulfate and ammonium sulfate part. So this is the different type of your salts. There are a couple of more type of salt. Let me give you one more example. It is known as complex salt or coordinate salt. So complex salts are like this, K4 FeCN whole 6. In second year, there is a beautiful chapter known as coordination chemistry. You are going to study there. So complex salt or coordinate salt or coordinate compound is like this. This is known as counter ion. You will read in future, and this is known as complex ion. So counter ion is outside the square bracket and complex ion is inside the square bracket. In complex ion, this iron is known as central metal atom, which is generally D block. And this CN is known as ligand. Ligand for you means those molecules or ions which are rich in electron. They have more electron rich. They are negative in nature. So this is example of your complex salt. This is your counter ion, complex ion, central metal atom, ligand, and this 6 number is a coordination number. All this you will read in 12th grade in coordination chemistry chapter. Very good chapter, one of the very good chapter of inorganic chemistry. So that's all with respect to type of salt. Let me give you a gist. You have simple salt, acidic salt, basic salt, double salt. Simple salts basically made up of strong acid, strong base. Acidic salt made up of strong acid, weak base. Basic salt made up of strong base, weak acid. Double salt made up of two or more than two type of simple or neutral salt. Good. Now this is a representation of your acid, basis, and salt. HCl is acid. How? Because when you dissolve in water, it produces H plus ion. So Bapre Bap and Are Bapre, you remember, litmus will help you to identify that. NaOH is the base. Why? Because when you dissolve in water, it is forming OH minus ion. You can see here, H plus is smaller in size, OH minus is bigger in size. Later we will discuss this also concept. That ions, they are of not same size. The ionic sizes are different because of various factors like number of protons, etc. And salt, when you dissolve in water, it is Na plus and Cl minus. Now, one important thing, from base Na is coming, and from acid Cl is coming. So Na from base and Cl from acid combining to give NaCl. That's why it is known as neutralization reaction. And this H and this OH combine to form water. So this is neutralization reaction representation, how it looks. Let's move to an important concept known as pH or pH scale. Now, by now we know that you have molecules or compound which is acidic, which is basic, and which is salt. Salt can be acidic and basic. Now, how to identify that this compound X is acid, this compound Y is basic? There must be some logical reason for that. So there was a scientist known as Sorensen in the year 1909. In Carlsberg laboratory, he found out a tool to find out the pH known as pH scale. pH scale is what? It is a scale just like your ruler. 14 numbers are there, 0 to 14, 0.0 to 14.0, where 7.0 generally becomes neutral. Generally word I have used. 14 is highly basic and 0 is highly acidic in nature. Okay, and they are given different color code. Generally, the Acids are in the orange, red and yellow zone, whereas the bases, they are purple, indigo and the blue zone. We are going to see that. Now, what pH stand for? How to write pH? P you will write like this and H you will write it as a superscript. pH stand for power of hydrogen. You are right. Hydrogen means H plus ion. Another name for this is potenge of hydrogen. Potenge, which itself means power. So power of hydrogen or potenge of hydrogen, the full form of that. pH concept considered the presence of H plus ion. So then for basis, what it is known as, it is POH. But our focus at this point of time is only on pH. So what is pH? So we often hear that certain substances are acidic or basic in nature. But how does one find out whether a substance is acidic, basic or neutral? That is pH 7 for neutral. What make a substance acidic and basic? You know, presence of H plus acidic, presence of OH minus basic. Now, how to find out which is acidic or basic? For example, I give you two test tubes. It contain HCl and it contain NaOH. When you see them, it is a colorless liquid like water. You cannot differentiate. One way you put your hand inside, if it is slippery, it is base. But other way, if you put your hand inside, it will corrode your skin. Acids are corrosive in nature. So what do? You take the pH paper inside or the litmus paper inside and find out the answer for that. So all these are determined using the concept of pH. pH stands for power of hydrogen or potenge of hydrogen. pH is a numeric scale. Values are there from 1.0 to 14.0 in chemistry, that is used to find out whether a substance or solution is acidic, basic or neutral in nature. This concept was given by Sorensen uncle, a Danish chemist, in the Carlsberg laboratory in the year 1909. He established this and later it was edited and standardized in the year 1924. So the pH scale somewhat look like this. This pH 7.0, which is the green zone, this is neutral. We expect most of the thing to be neutral in life, but it is not. The highly acidic one is in the red, it is 0. Most acidic, then it is slight lesser, slight lesser, slight lesser, slight lesser, lesser like that. So most acidic to least acidic and then neutral. Least basic to most basic, and this is the neutral part. So if you're highly acidic, red color, the litmus. If you're highly basic, completely purple color or the blue color. Okay. And if you're neutral, it will be green color. Do you think that is the maximum scale? No. There is a super acid, pH is minus 28. Can you tell me what? Super acid, whose pH is minus 28. The name is fluoroantimonic acid, highly basic, highly acidic in nature. Can you give me one example of the highest basic molecule? It is NaOH, 14 number. Fluoroantimonic acid is minus 28, whereas NaOH is 14. Just for your knowledge. So this is the basic slide with respect to your pH and pH scale. Now let's discuss about the various values, whatever you have. Do you have any idea what is the pH of the blood? Acidic or basic? pH of the blood. Find out. Do you know the pH of Taj Mahal is between 7 to 8? Correct. Taj Mahal. Now this is your pH scale. This is water, neutral. Milk is here around 6. Coffee is there around 5. Tomato, that is the oxalic acid, around 4. Soda. Okay. What you drink, consume. That is sodium carbonic acid. Then you have citric acid with around 2. Then you have stomach acid. Our stomach has HCl. Even if you put a metal inside like blade, it is going to digest that, but don't do that. Don't do that. Don't do that. Okay. I'm just giving an example. Then you have batteries like, what is that? You have nowadays many different type of batteries. Nickel cadmium is there, mercury is there, a lithium ion is there. I'm talking about lead sulfate sulfuric acid battery. Okay. Egg, it is slightly basic. Baking soda, basic. Soap made up of NaOH, basic. NaOH in the dilute form. Ammonia, basic. Bleach, CaOCl2, calcium oxychloride. It is also basic. Bleaching powder. Then 13 and 14, your strong alkaline solution like NaOH and KOH, they are highly basic in nature. These are the values. Apple, it is acidic, 3. Banana, it is 4. Butter, it is 6. Water, this is I'm talking about distilled water, not tap water or the river water or the ocean water. They will have different values. Lime water 12. Lime water is what? Calcium hydroxide, not lime juice. Milk is around 6. Vinegar is 2. Baking soda 9. Eggs around close to 8. Black coffee 5. Highly acidic in nature. Tomato juice 4. Chocolate 5. Rice 6. Shampoo between 5 to 7, depend on the brand and the ingredient what they use. Honey between 4 to 6. Mango basic. That's why you get acidity if you eat lot of mango. Sugar 7. But it's a very ideal condition. It is not exactly 7 every time. Carrot 6. Potatoes between your 5 and 6. Okay. What do you think? What will be the pH of the blood? It is having a range 7.35 to 7.45. Okay, that is the range you remember. Now you will tell that, sir, suppose I drink lot of Coca-Cola and I drink lot of Pepsi or Fanta. I'm sitting, okay. Then do you think the pH of the blood will change? Answer is no. The pH of the blood will not change. Why? Because there's an important concept known as buffer. Buffer solution. Buffer are those chemicals which resist the change of the pH of the blood. Otherwise, if you drink 2 liters of Coke, which is containing carbonic acid, your blood must become acidic, right? And cause harm to you, but it is not causing harm to you. Why? Buffer. So buffer are those chemicals which resist the pH change, just for your knowledge. So this is all about your pH scale. I think the next slide is the question of the day. So this you are going to find out in session 5. I'm going to discuss this. The acid present in the honeybee blood I have given just now. So find out that. Taj Mahal, I think I have given you the example, right? What is the pH value? It is between 7 to 8. Now that's all from today's session. We will keep it here. Now bleach I have written, no, CaOCl2. It is also known as mixed salt. So 6 type of salt is mixed salt. Bleach is one of the example for you. So in today's session, let me give you a nutshell. We discussed the question of the day of the session number 3. Then we started with acid and bases, their old type of characterization, sour, bitter, slippery, corrosive, like that. Then we discuss Arrhenius concept, that acids are those which produce H+, bases are those which produce OH-. I even said that there are 5 type of concept of acid and bases: Arrhenius, Bronston, Lowry, Lewis, Lux, Flood, and then you have Sanovich concept. But first three we are going to discuss in the first year of your syllabus. Then we discuss that the demerit of the Arrhenius. Then we discuss what is dissociation, ionization. 2 different type of acid and bases, strong and weak. What is degree of dissociation? The different type of salts we discuss. First we discuss what is salt, the neutralization reaction. Different type of salt: simple, acidic, basic, neutral, not neutral, double. Then I give you example of complex salt. Just now I have given you example of mixed salt, that is for the bleach part. So these are the things. Then we came and discussed about what is pH, what is pH scale, what was the necessity to get that. Then we discussed your question of the day here. So that's all from today's topic. We discussed about acid, bases, and salt. I hope you understood this topic. Let's meet in the next session. Till then, खुश रहो, आबाद रहो, जहां भी रहो. Be happy. Take care of your health, love your parent, respect them, love your juniors, and don't waste this vacation time. Utilize it, understand the bridge course, because whatever we are going to do now, it is your foundation. On this only we are going to build the Burj Khalifa for you. That's all from today. Tata, bye-bye, take care, and God bless you all.